My name is Jamariya Howard, and I study FR20 NADP oxidoreductase. This enzyme can be found in methanogenic organisms. And I'm looking at how this enzyme regulates NADP production within the methanogenic organisms. FNO, this is the crystal structure of FNO. It is a 48 kilodalton homodimer. So if I were to take this and split it down the middle, we would see two identical subunits. To the right is an expanded view of the active site, which contains one FR20 cofactor molecule and one NADP plus molecule, which is about 3 angstroms apart, which is a good distance for hydride transfer to occur. The structure of the FR20 cofactor contains one 6-member fused ring system known as a diazo-isoalloxazine ring system. With the addition of the ribitol, it becomes FO. When it becomes phosphorylated, it becomes F+. With the addition of the lactose group, it becomes FR20. And this is a polyglutamate tail that can range anywhere from 1 to 9 repeats depending on the species in which it's found. The FR20 cofactor shows a large absorbance at 420 nanometers. And upon reduction, it loses its absorbance at 420 nanometers and gains a shorter at 340 nanometers. FNO catalyzes the reversible reduction of NADP to NADPH. The reduced cofactor transfers a hydride from the 5th position over to the 4th position on NADP, producing NADPH and oxidized cofactor. This is an expanded view of the subunit interface. This interface is located between the two subunits. And essentially with this project, what we wanted to do was to take these amino acids that you see here and create a library of mutations. So what we wanted to do first with these library of mutations, we wanted to do binding studies. So with these studies, what we actually did is compare them to wild type, which was done by Ebenezer Joseph and Kong Lee. So what they found with the wild type form of the enzyme is that they seen that they had a KD of 3.6 plus or minus 0 for FO, and for NADPH they had 2 plus or minus 0.3, meaning that they had tight binding. But what was most important is what they seen with the Hilli coefficient. When they fit this data to the Hill coefficient, they seen a number that's less than 1, indicating negative cooperativity. If you see a number that's greater than 1, that is indicative of positive cooperativity. If you see a number that is equal to 1, that is the indication of no cooperativity. For the variance, we actually seen a decrease in the binding affinity for both FO and NADPH. But what was most interesting is what we seen for the NADPH Hill coefficients for these variants. So with the exception of T192A and the H133 variants, all of these variants actually displayed a change from negative cooperativity to no cooperativity. But the T192A and the two H133 variants still displayed negative cooperativity kinetics. We took it a step further and we also conducted steady state experiments. For the variance in comparison to wild type, what we actually seen was that the variants were much slower than what we seen for the KCAT turnover for wild type FNO. And we also seen a decrease in catalytic efficiency for all of these variants, indicating that all of these amino acids are important in catalysis. We then took that steady state data and fit them to double reciprocal plots. For the double reciprocal plots, if you see something that's downward and concave, that is an indication of negative cooperativity. If you see something that's upward and concave, that is an indication of positive cooperativity. And if you see a straight line, that is an indication of no cooperativity. So all of these variants, with the exception of T192A, all display no cooperativity kinetics. But if you take a look at the T192A variant, you still see that downward and concave curvature, indicating that we still see negative cooperativity kinetics. With the pre-steady state for wild type, Ebenezer Joseph and Conley actually seen a phenomenon called biphasic kinetics, indicating that they've seen a fast phase and a slow phase. But for all of the FNO variants, we no longer see that fast phase and that slow phase anymore, indicating that we don't see biphasic kinetics with any of the variants.